Section 4.8 Complex Numbers. Today, students will be able to simplify, add, subtract, multiply, and divide complex numbers. We are going to first start by talking about the imaginary unit. And the imaginary unit is the letter I. And I represents the square root of -1, so now we can simplify anything that's negative under our radical. Also, if you were to square both sides, I squared equals -1. So make sure you have both of those memorized so that you can easily go back in between I and I squared. First, we are going to start by simplifying with the letter I. So let's look at our first example, and that's going to be the square root of -5. Okay, so -5 you could rewrite as -1 times 5, since -1 times 5 still gives you -5. Then using the radical product property, you can simplify that to the square root of -1 times the square root of +5. So on the earlier slide, you learned that the square root of -1 is I, and then you can't simplify the square root of 5 anymore, so your answer just became I times the square root of 5. Our second example is the square root of -4. So I'm going to rewrite that as -1 times +4, because -1 times 4 gives me -4. Then use the product property using the radicals, so the square root of -1 times the square root of 4. The square root of 4 gives me 2. The square root of -1 gives me I, so your answer is 2I. So in the book, you are normally always going to see a number and then the letter I. When there's radicals, you'll see I and then the radical. It doesn't necessarily matter which way you write it, just make sure that the I is not under the radical anymore. Our last example in simplifying is going to be the square root of -12. So we're going to separate it as -1 times 12. And then separate them into their own radicals, so the square root of -1 times the square root of 12. Now I know the square root of 12 isn't a nice number, but you want to see if you can break it down. So 12 is 4 times 3 or 6 times 2, either way you get the same answer. 4 is 2 times 2. Remember, you have to circle two of the same numbers, and so since there are two 2's, that 2 is going to come out in front. Since this 3 isn't circled with anything, the 3 stays under the radical. You don't use the 4 because you broke down the 4 into the 2 and the 2. And then lastly, the square root of -1 is I, so your answer is 2I root 3. Now let's look at complex numbers. So complex numbers are written in the form A plus BI. The A is used for the real numbers. The BI is used for the imaginary numbers. And you know that the B is the imaginary part because it has the I that follows it. We can also graph complex numbers. So instead of having the coordinate plane X and Y, we now have the real axis and the imaginary axis. The absolute value of complex numbers is going to find the distance from the origin to the point that lies in the complex number plane. So to find that distance, you would take the complex number, which is A plus BI, and to find the absolute value, you're going to take the real term and you're going to square it, and then you're going to add it to just the imaginary term, just the B, not the I. You're going to take B and you're going to square it, and you are going to take the square root of the sum of those two numbers. Okay, now we are going to look at graphing the complex number 5 minus 3i. So since the 5 doesn't have the I with it, 5 is the real part, the minus 3i is the imaginary part. So let's go to draw our graph. So remember, the x-axis is now the real axis. The y-axis is now the imaginary axis. And +5 would be to the right, 1, 2, 3, 4, 5. And then minus 3 is going to be down 3. And it's basically like you're plotting the point 5, negative 3, okay? So now let's also find the absolute value of the complex number 5 minus 3i. And the absolute value is going to tell me the distance from the origin to my new point, okay? So remember, the absolute value is a squared plus b squared. Take the square root. A is 5, so we're going to do 5 squared. B is minus 3. Make sure it's always addition. 5 squared is 25. Negative 3 squared is 9. 25 plus 9 is going to give me the square root of 34. And you would try to break down the square root of 34, and you can't do it. So the distance from the origin to my blue dot is a distance of the square root of 34. Press pause, and I want you to try graphing the complex number just 2i. Alright, so if you notice, the 2 has the I with it, so this is my imaginary part. 2 is actually the b. Since there is no number in front of the 2, when we go to graph this, we're not going to move any left and right because there's no number. So, since 2 is positive, we are going to go up 2, and we're just going to put a dot on the imaginary axis. So then the absolute value is going to find the distance from the origin to that point. Remember, the absolute value is a squared plus b squared. Since there is no real part, a is just 0 squared plus, and then b squared, which is 2. 0 squared is 0, plus 4 gives me the square root of 4. And the square root of 4 gives me a distance of 2, which should make sense. You could count from 0, 0 up 1, 2, and you get the exact same thing. Now we are going to look at how we add complex numbers. So we're going to start by adding 7 minus 2i plus negative 3 plus I. So to do this, all what you're going to do is combine like terms, and that means combine the real number with the real number and the imaginary number with the imaginary number. So please don't forget that this is a plus sign. You're adding, you're not multiplying. So 7 plus negative 3 is going to give me 4. Negative 2i plus I is just going to give me minus I. And so when I add 7 minus 2i plus negative 3 plus I get 4 minus I. Press pause, and I want you to try adding the two complex numbers negative 3 plus 9i plus 3 plus 9i. So remember, all we're doing is combining the real number with the real number. So negative 3 plus 3 gives me nothing. It gives me 0, so you don't need to write the 0 down. And then 9i plus 9i is going to give me 18i. So when you add the two complex numbers together, you get 18i as your answer. Now we are going to move on to subtracting complex numbers. And subtracting complex numbers is almost as easy as adding them. You just have to do one step before you can combine the real numbers with the real numbers and the imaginary numbers with the imaginary numbers. So the first step is going to be to distribute this minus sign to the 3 and the 2i, since you are subtracting all of that. So that's going to make it minus 3 plus 2i, remember it changes both of their signs, and then you're just going to bring down the 1 and the 5i from your original complex number. Now we just get to do is add the real numbers, so 1 minus 3 is going to give me negative 2, and then the imaginary numbers, 5i plus 2i is going to give me 7i. So first thing, distribute the minus sign, which is going to swap both signs, and then combine real with real and imaginary with imaginary. Press pause and try subtracting 8 plus 6i minus 8 minus 6i. So the first thing you're going to do is distribute your minus sign, which is going to change both signs. So it's now minus 8 plus 6i, and then bring down the 8 and the 6i from the original complex numbers. So now combine 8 minus h, which gives you 0, and then 6i plus 6i gives me 12i, so my answer is just 12i. Now we are going to multiply complex numbers. So our first example is going to be 7i times 3i. So we're going to multiply 7 times 3, and that gives me 21. And then we're going to take I times I, which is going to give me I squared. Okay, one of the very first slides we wrote down that I squared equals -1, so I'm going to replace I squared with -1. And then 21 times -1 gives me an answer of -21. Now we are going to look at multiplying 2 minus 3i times 4 plus 5i. So now, since they both have real and imaginary parts, we are going to have to FOIL these two together. So we're going to start with the first number times the first number. So 2 times 4 gives me 8. And then the O stands for the outer, so 2 times 5i is going to give me 10i. I stands for the inner, so -3i times 4 gives me -12i. And then the L stands for the last, so -3i times 5i gives me -15i squared. Okay, now we need to combine like terms, so the 10i minus the 12i is going to give me -2i. Bring down the 8, bring down the -15. Then right here we see that 15 is being multiplied by I squared, so I'm going to replace I squared with my -1. -15 times -1 gives me +15. Bring down the -2i, bring down the +8, and then you combine the 8 plus the 15, and that's going to give me 23, and then -2i, because there's no other imaginary terms for me to combine with. Now, you always want the real part to come first, which is why we wrote the -20 or the +23 first, and then the 2i, since it has the I, it needs to come last. Press pause, and I want you to try multiplying -4 plus 5i times -4 minus 5i, and don't tell me that you get 0 as your answer. Again, since they both have real parts and imaginary parts, we have to FOIL this. So we're going to start with the first times the first. -4 times -4 gives me +16. Outer, -4 times -5i gives me +20i. Then the inner numbers, 5i times -4 gives me -20i. And then 5i times -5i gives me -25i squared. Okay? Combine like terms. 20i minus 20i makes that cancel out. So we're left with 16 minus 25. And then replace I squared with -1, since I squared equals -1. -25 times -1 gives me +25. And 16 plus 25 is going to give me 41. So if you look at this original problem I gave you, -4 plus 5i times -4 minus 5i, I hope you notice some things that are the same. They're both -4. They're both 5i. One of them gets a plus sign though, the other one gets a minus sign. So when only the term in front of the imaginary term has been changed from one being positive to the other one being negative, these are called complex conjugates. A complex conjugate is A plus BI times A minus BI. Again, the real parts are the same. The imaginary part, one is positive and the other one is negative. When you're multiplying conjugates, you get to use a shortcut. You just square A and you add it to B squared. Okay? Every time they're conjugates, you are going to get a nice answer of just a number instead of a real part and an imaginary part. The last thing we're going to look at in this 4-8 section is dividing complex numbers. And when we divide complex numbers, we're actually going to have to use the conjugate that I just showed you. So let's look at our first example. 5 minus 2i divided by 3 plus 4i. Okay, so just like when we were dealing with radicals earlier, you can't have radicals in your denominator and you can't have i's in your denominator. So to get rid of the I that is currently in my denominator, I have to multiply by the conjugate of just my denominator. So the 3 needs to stay the same because the real part is the same. The 4i needs to stay the same. And then since this one has a plus, this one over here is going to have a minus. Whatever you do to the bottom, you are also going to have to do to the top. So we are going to take and we have to FOIL the top, and you could also FOIL the bottom, or you can use the shortcut that we learned earlier, a squared plus b squared. So I have to FOIL the top though, so 5 times 3 gives me 15. 5 times minus 4i gives me minus 20i. Minus 2i times 3 gives me minus 6i, and minus 2i times minus 4i gives me positive 8i squared. Okay, in the denominator, the real term is the 3, the imaginary term is the 4. If you were to FOIL the bottom, you should get the exact same answer. So now bring down the 15 from the top. Minus 20i minus 6i gives me negative 26i. Bring down the 8. And I am going to replace that I squared with that minus 1. Okay, 3 squared in your denominator is 9. 4 squared in the denominator is 16. So, rewrite the 15 minus 26i. Positive 8 times negative 1 gives me negative 8. And 9 plus 16 gives me 25. Okay, then we're going to combine the 15 minus the 8, so that way we can have the real terms and the imaginary terms, and that's going to give me 7 minus 26i over 25, and then you normally write them in standard form. So we would write 7 over 25, and sometimes you could simplify that if you could. And then minus, since there was a minus sign, and then 26 over 25i. Either one of these right here means the exact same thing. Sometimes, though, you could simplify it to get a smaller answer than what you had when you had the 2 numbers in the top and the 1 number in your denominator. This is our last example, and it looks a little different than the example 13 that we just did. So, remember, I am not allowed to have i's in my denominator, so I need to get rid of my 3i. So you know that the 3i has to be there, and then you're just going to change the sign in front of the imaginary term. So since this is positive 3i, over here it has to be minus 3i. Again, you only change the sign in front of the imaginary term. Whatever you do to the bottom, you must also do to the top. So we're going to take 4, and we're going to multiply it by negative 3i, and we get negative 12i. We're going to take 2i and multiply it by negative 3i, and we get negative 6i squared. In the bottom, normally I could use my shortcut, but it looks a little different, so we're going to take 3 and we're going to multiply it by negative 3, and we get negative 9. I times I, and we are going to get I squared. Okay, I'm going to replace all my I squareds with negative 1, so that's going to give me negative 6 times negative 1, divided by negative 9 times negative 1. Okay, negative 6 times negative 1 is going to give me a positive 6. And then the negative 9 times the negative 1 is going to give me a positive 9. And then we need to rewrite this. The 6 and the 9, neither one of them have i's. So that leaves me with 6/9. And then minus, because there's a minus sign in front of the 12i, over 9. So, is there a number that goes into both 6 and 9? Yes, that's 3. So 6 divided by 3 is 2. 9 divided by 3 is 3, minus, and then 12 divided by 3 is going to give me 4. 9 divided by 3 is going to give me 3, and that would be how you simplify this complex number.